Right, hello. We are soon going to start solving rational equations, but before we do that, we need to first cover a really important part of it, which is finding the lowest common denominator of fractions. We'll be using LCD for that. But first, even before we do lowest common denominators, we're actually going to start even with lowest common multiples. This is something that you do like back in elementary school when you're first learning how to count by twos, 2, 4, 6, 8, count by threes, 3, 6, 9, 12. You learn about these things called multiples. We'll use them for denominators in a bit. Now there are going to be some variables thrown in there, so take a look at example 1. We've got 3 and then we have 5x. So when we're looking for a lowest common multiple, we're counting by threes, like because that's one of the terms we're dealing with. So 3, 6, 9, 12, 15. Oh, my handwriting getting pretty crazy over there. 18, and so on. And then you do the same thing with the 5. Now there's an x involved, but it's still, counting by 5s. 5x, 10x, 15x, 20x, and so on. And so your least common multiple, well, what do they both hit? The first number that they both hit, because they can hit more than one if you keep going. But 15, 3's go into 15, and then 5, 10, 15x. Yeah, there's an x attached there, so we're going to end up including that in the common multiple. You'll see why a little bit later with when we start to solve why that's going to be important. All right, so the lowest common multiple, or the least common multiple, is 15x. So then if you do the same thing in the next example, kind of invaded my own space here, we've got 2, 4, and 3. So you do the same kind of thing. Count by 2s. 2, 4, 6, 8. Count by 4s. 4, 8, 12, 16. Count by 3s. 3, 6, 9, 12. And you can list them out if you want. That's always a helpful thing. But if you do list them, you would find that 12 would be the first number that they all go into. It's a multiple of 2 and of 4 and of 3. It's the first one that they hit, the lowest one. Because there are x's involved in, just like the previous problem here, that means you're going to have an x involved in your answer. All right, so then moving on to the next one. So again, same kind of idea. Finding multiples, so counting by 7. So 7, 14, 21, 28, yada, yada, yada. 1 is kind of an interesting number because it's always just a 1. 1 goes into everything, basically. So everything's a multiple of 1. 1 times 1 is 2. Or 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 can go into every single number because every number can be divided by 1. So 1's kind of like a freebie. Think of it that way. And so then we've got, if you want to list it, 1, 2, 3, 4, like you could keep doing that. 2x, you're going to write 2x, 4x, 6x, 8x, and then keep on going, 10, 12, 14. So then this one, they'd both end up hitting 14. 1 would eventually get to 14. 2, 4, 6, 8, 10, 12, 14. It would get there as well. So 14, but then there's x's involved in this problem because this one has an x on it. X. And then the last one, same idea, finding multiples, count by 5s, 5, 10, 15, 20, count by 2s, 2x, 4x, 6x, 8x, and so on, count by 10s, 10, 20, 30, and there's x's involved. So we know that there's going to be an x as a part of the lowest common multiple. Count by 5s, count by 2s, count by 10s, they're all going to hit 10, actually, 10 itself. Right, so you might have been thinking possibly 20. This is 5, 10, 15, 20. 2 will go into 20, 10, 20. But 10's the lowest one because 2 and 5 are both multiples. Like they both go into 10. So that is finding lowest common multiples. All right, now this idea is going to extend into fractions. So what we've been doing with rational expressions is we've been working with fractions. You've been seeing that. So then to solve rational equations where we're going to add and subtract these fractions together, fractions have to have a common denominator. That's just an automatic thing. If you're going to be adding fractions, that you need to make sure that they have before you can start adding them or subtracting. Common denominator. You didn't need that to multiply and divide, you saw that. But to add and subtract has to be the same denominator. So we're going to use this idea of a lowest common denominator, which is just like finding the lowest common multiple. It's just that now they're at the bottom of the fraction only. So here's what it is. If we're going to find the lowest common denominator, for example 1, we're looking for the lowest common multiple, but we're only looking in the denominator. So I don't care about the 1 and the 2 at all. All I care about is the 3 and the 9. That's what matters. So again, you think about your multiples. Count by 3s, 3, 6, 9. Count by 9s, 9, 18. Well, they're both going to hit 9 first. It's the first number they'll both hit. They'll hit other numbers the same, but 9's the first one. No x, because 3 and 9, there's no x's on those. All right, so then we can extend this idea a little bit further and now look at, well, they have full equations here instead of just like 1/3 and 2/9. Now it's a setup for what we're going to be solving. Same thing though. We're looking for lowest common denominator. So all you care about is what's happening in your denominators only. That's what we're looking at. And so now we're thinking about, okay, count by 2's, or x. So 2x, 4x, 6x, 8x, and you can keep listing them if you need to, because then you have to do the same thing for 7, 14, 21, you can keep listing, and then x, that's 1x, so remember 1's are kind of freebies. It's going to go 1x, 2x, 3x, because 1 will go into every single number. Alright, so if you were, I didn't extend my 2's out very far, but if I did, it would hit 14. 2, 4, 6, 8, 10, 12, 14. And then 7 hits 14. 1 is a freebie. 1 will hit 14. It'll get there because you can do 1 times 14, get 14. Anyway, so 14 is going to be the number that we need for our lowest common denominator, but there are x's involved in the problem, so we're going to need 14x. Alright, and then just keep on moving along. Same kind of thing. Don't worry about the whole setup. Remember, all we're looking for is the LCD, the lowest common denominator. So all you look at is these numbers here. Don't worry about the other ones. The numerators can be anything. So if you count by 10s, again, you can list it out. 10x, 20x, 30x. Probably don't need to go too high on the 10s. Count by 4s. That's the next denominator. 4, 8, 12. 16, 20, 24, blah, blah, blah. And then 2x. 2x, 4x, 6x, 8x. You can keep listing that out. I'm going to kind of think about it in my head because I see that the 10 hits 20. So one of your multiples here is 20x. This one also has a 20 in it. 20 is an even number. 2's always going to even numbers, so if you kept counting, 2, 4, 6, 8, 10, blah, 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 you'd get to 20. So it turns out that 20, 20, this one down the line will hit 20, 20, but there are x's involved, so 20x. That's it, done. Okay, just a few more to take a quick look at. Some interesting ones like these with whole numbers. Remember that whole numbers are technically over 1, so that's like 7 divided by 1, still 7. So really, all we're looking at in the denominators is the 6 and the x, and then the 1 is the freebie. So if you count by 6's, 6, 12, 18, if you count by 1x, 1x, 2x, 3x, it's all going to end up hitting 6. And there's an x involved in the end. Notice that this one's basically like just a combination of these, and one's free. Alright, so then the next one, these are definitely kind of strange looking, maybe a little frightening at first, but look, this whole thing is a factor. We've been working with factors pretty recently. X plus 5, x plus 5, they're going to group together. So x is not really separate from 5. It's one thing, x plus 5. And then the 1 is a freebie. So there are two denominators that are already the same, the x plus 5. So that itself is going to be the lowest common denominator, the x plus 5, which is already common for two of them. The 1 is a freebie. Technically, what this would be is 1 x plus 5 with the 1 there, but you don't have to multiply by 1 technically. So x plus 5. All right. Now the last one, again, same kind of thing, just one more so you can see it. Remember that whole numbers are technically over 1, so the only things we're looking at are these in the denominator, 1 being the freebie. So the lowest common denominator is 1, and then the x minus 3, which is, like, consider it as being grouped together as a factor, because those don't separate with that subtraction in there. So the LCD is the 1 and then the x minus 3, or just the x minus 3. You can have it in parentheses or not for the LCD. When we start to solve, we'll probably want it in parentheses, but we'll get to that. All right, and that is finding LCDs. Once you get this skill down, solving it won't be such a monster of a problem. Really won't. All right, so then you've got a practice assignment to try out these LCDs.